Hi guys, welcome back to the channel. And today we are back with one of the NPTEL courses that is known as Design and Analysis of Algorithms. So we will be taking all the quizzes that are coming up later in this week also and upcoming weeks also. So this week's quiz is now available in your dashboards if you have already enrolled in this particular course. So let's get started. Okay, so if we see the very first problem, it is based on input-output problem. It is you are given a piece of code and you have to give the output of this particular piece of code. So let's see how we normally solve these kind of problems. Okay, so whenever we have to solve such problems wherein you have to give an output for a particular piece of code, so my suggestion would be go line by line. So starting with the first line, what it says, the first line says that the function is being passed with two parameters, that is m and n. So write those parameters m n and assign them the value that has been given to you. So the value are 2003. So 2000 is the value of m and n is having the value as 3. Okay, perfect. So the second variable is answer. So answer variable, I'm writing it over here for the sake of easiness. You'll get to understand in the later part of the code that why I written this particular piece of thing over here. Okay, so if you see the answer is being denoted as 1. So I'll take the initial state of answer as 1 and initial state of count is given to us as 0. Now, let's start off with this particular while condition. This while condition says that answer has to be less than or equal to m. So initially the answer is 2000 and m, sorry, uh, answer is basically 1 and m is 2000. So what will happen? We can enter the while condition as the while condition is being satisfied perfectly. So what is the first line? The first line says increment your count by 1. So this is nothing but count plus plus is something that is happening. So you can also imagine count plus 1 as count plus plus also. So count will get incremented to 1. At the very next step, what is happening is answer is getting uh, enhanced to answer into n. So answer into n basically means 1 into 3. So every time answer will be getting multiplied by 3, right? So what is to be done is 1 into 3 is 3 itself. So moving further, what will happen? Again, there will be a check that 3 is less than equal to 2000. Oh, of course it is. So count will get incremented and your answer will get updated as 9. Now again, we enter into the while loop and the while loop says, is 9 less than 2000? Oh, yes, it is. Then what will happen? Your count will get incremented to 3 and your answer will get updated to 27. Now again, there will be a check. Is 27 less than or equal to 2000? Oh, yes, it is. Then what will happen? Your count will get updated as 4 and yeah, your count will get updated to 4 and your answer will get updated to 81. Now again, your count will get updated as the while condition has been satisfied that 81 is less than or equal to 2000. So again, your count will get updated to 5. In the next step, answer is getting multiplied by 3. So again, 81 into 3 is 243. And your while condition will again get satisfied as 243 is still lesser than 2000. So this will get updated to 6. Now 243 will get again incremented and it will become to 729 and your count will again get incremented. And your answer will supposedly be somewhere around 2163. I think so, yeah. So 2163 would be your answer and this would be your termination point and this would be the point wherein you will be returning your count function and the count answer would be as 7. So the answer for this particular question was 7. Okay, moving ahead. The next problem says that suppose someone designs a new airline routing algorithm uh, called magic path and claims that its worst time complexity is order of n square log n. Which of the following statement is inconsistent with this particular claim? Okay, so before starting ahead with all the options that are given to us, I would like to give you few insights about worst case complexity, what the worst case complexity is. Okay, so I'll just quickly clear this up. Okay, so whenever we say that the worst case complexity of any algorithm is n square log n, so this is what is given into in our question. So what is actually means that in the worst case, in the worst input case that is given to us, our algorithm will hit at most this complexity. Beyond this, it will never go. It can never go to n cube. It will never go to n raised to power 4. It will never go to n raised to power 5. But yes, this is the limiting case wherein our algorithm is dicey or might be exceeding the time, right? So this, let's say if order of n, if order of n is something takes around 5 hours of analysis, order of n square log n would take much greater than 5 hours. So this is what I meant. But when we talk about worst time complexity, worst case time complexity, so that means your code will never ever go beyond this particular point. That let's say if it is 10 hours, n square log n is 10 hours. Your code at most will go until up till 10 hours of computation, and it will never reach beyond it, right? So now if this logic is clear to everyone, so I think now getting back to the problem would make much more sense. So what does the first option says? The first option says that for every n, for every input size of n, magic path is able to solve the problem in time complexity n square. Yes, it is possible that our uh, code might be going up to the complexity of n square, right? Because n square log n is the upper bound. Beyond this, the code will not go, but it can, the n square log n can be reduced to n square also if the input case is good enough for the computation, right? So what is the second option? The second option says that for some n, for every input of size n, magic path is able to solve the problem in time proportional to n square. So this is same statement written over again. So I think yes, this is also possible. For every sufficiently large n, there is an input size of n, which magic path requires time proportional to n square. Again, if the if even if the it's a very large input size, then also yeah, I think n square will definitely come fit into n square log n. Now let's see into the last case. The last case says that if the size is sufficiently large and the input size is given as n, the magic path algorithm will actually go into n cube. Now this is the point which I wanted you to stress upon, that n square log n is already our upper bound of the magic path algorithm. How it can compute in n cube, right? So this is the very option that says that the statement is very inconsistent to what it actually requires. Okay, so moving ahead. Now, the third problem is more of a mathematical, wherein we need to compute that what can be the uh, approximate number of hours for computation the machine would take computation for. Okay, so let's see. So it says that the worst time complexity is order of n raised to power 4, and the CPU can perform 10 raised to power 8 operations per second. What is the most accurate guarantee for the time required to solve the input size of 800? So if we take this, let's take this on a whiteboard and understand what it actually means. Okay, so you are given n raised to the power 4 as the worst time complexity, and your n is basically 800, and your time is 10 raised to the power 8 operations per second, right? If it is so, then we need to compute that what will be the overall time complexity or overall time required to for the algorithm to assess these 800 800 sample space sample test case that is given, right? So what will happen? We have to do 800 raised to the power 4 because these many number of operations is something that we have to perform in 10 raised to the power 8 seconds. So this is the basic mathematics that you need to perform. That 800 has to be or multiplied 4 times, and then you have to divide it by 10 raised to the power 8. If you do the math correctly, the answer would come as under 5 hours. Right. So moving ahead, the fourth problem is a little tricky, but yeah, I'll try to explain with the best of the knowledge that I have. So suppose there is a function that is n square log n. Consider the following statement. So the first statement says that f of n is o of n, n square root of n. Okay, so even if you consider root n, so it will never be very close to f of n. It will never reach near to n square log n also. So I think A will never satisfy that particular condition. If you go further, B part, so B part says that n square root n is actually your f of n. So n square root n can be at times be equal to n square log n for some special n's, because it is already maintaining that n square. So root n has to be equal to log n. And for some cases, there might be a possibility where log n will be equal to square root of n. Right. Now, the C option is also valid at points where log n is actually equal to n. So there has to be certain n where wherein your um, log n is approximately equal to n. So in those cases, f of n can be equal to n cube. So the B option and the C option are the most relevant ones, but yes, A can never be the answer. And the reason for this is, even in the worst case, the square root will never reach to it. It will never reach to an order of n cube. Sorry, never reach to the order of n square. It will be always lesser than n square, right? So yeah, so this option is basically correct, that B and C are true, but A is not. Okay, coming on to the very last problem. So the last problem says that we are given an input fragment and there is some first and the last integer, and we need to compute whether the number is a composite number or a prime number or not. So in this particular case, I would just give you a very small hint. Just think about a problem, think around a test case and try to solve it. Okay, so I'll just brief you around a little, and I would like you to take a note that you will be solving it by yourself. If not, just comment down below if you have any doubts. I will be more than happy to reply to each and every comment that come up. Okay, so if you see in this code, the k value is actually getting incremented at each and every point, irrespective of any if conditions, right? Because there are no if conditions, so that means that k will always get incremented by the factor of m. So if k is getting incremented by k of factor m, so what is happening next? So I will always be getting incremented if the number is composite. Else, the j factor will get decremented by the same factor of n. Now, think around a problem that if the number that you have chosen is a composite number, so doesn't it mean if k will always get incremented, it should always be equal to I and j has to be 0, because the number that you are thinking of is a composite number, right? So if j is 0 and I is equal to the composite number and k is also a composite number, then which of these condition will satisfy? I think j plus I is the most relevant answer, and it will fetch you the correct answer if the number is a composite number. With this, we come to an end for this particular week. If you enjoyed the session, do like the video and subscribe to the channel. And do let us know in the comment section if you have any further doubts. I'll be more than happy to assist each and every comment. Thank you and bye-bye.